Dimensional analysis. This worksheet is going to help us take some units and transfer them to other units accurately. And what we're going to do is we're going to use a format or a structure that's going to work regardless of the units that we are converting from. So converting means going from, say, miles to feet. And although this is a chart of some dimensions, some units of measure, and showing what they are equal to in another unit, it is not necessarily complete. So here we can see we have 1 mile is equal to 5,280 feet, and that 1 inch is equal to 2 5,400 centimeters. 3 feet is equal to 1 yard. 454 grams is equal to 1 pound. 946 milliliters is equal to 1 quart. 4 quarts are equal to 1 gallon. And this is kind of an old English, you might say. A fortnight, which is not the game that boys like to play, but it's actually a unit of time measurement. So 1 fortnight is equal to 2 weeks. So what we're going to do is we're going to use the structure of dimensional analysis, and we're going to solve these problems. And it's really easy to do. The first one we probably could do without dimensional analysis, but dimensional analysis is handy when the problems become more difficult. So the way we do this is we take our first unit that is given to us, we take the given, and we write it down as it is. And labels are exceptionally important in dimensional analysis. And you'll see why in a minute. So what I'm going to do is I'm going to ask myself, if I want to go from inches to feet, is there any unit of measure that is in between inches and feet in my understanding of conversions? Well, there really isn't, but we do know that there is one conversion that we can think of that tells us how many inches are in 1 foot. So there's 12 inches in 1 foot. And so to go from inches to feet, we want to use this conversion ratio. Now, when I write it next to my given, this is my given, what I want to do is I want to either use a multiplication sign or the dot to indicate that we're going to be multiplying. And I'm going to write this information such that the unit of measure that appears in the given, I am going to put that same unit of measure as my second term in my ratio. So if I have inches right here, and you want to think of this over 1, I'm going to have inches as my second term down here. And because it's 12 inches are equal to 1 foot, I'm going to put my 12 inches on the bottom and my 1 foot up on top. The reason I'm going to do this is because in dimensional analysis, not only can I look at cross-canceling numbers, if that works out, and in this case it doesn't with 12 and 19, they don't have any common factors, but I can also cross-cancel my labels, my units that I'm measuring in. So if I have inches here, I can cancel out inches here. And what I'm left with then, the only unit of measure I'm left with is feet. So I know that my label is feet, and because I am trying to find feet, I am done with my multiplying in terms of setting it up. What I need to do now is multiply straight across the top and write 19 in my first term, and down below I'm going to write 12. And I canceled my labels, my units, inches and inches, and I'm going to just look at 19 twelfths of a foot. Well, I can change this into a mixed number, which would be 1 7/12 feet. So we know that 6/12 is about half of a foot. Well, is exactly half of a foot. So 7/12 is a little bit more than half of a foot. As a matter of fact, it's 7 inches, 7 out of 12 inches. So this is my first answer. 19 feet are equal to 1 7/12 feet. Let's go on and look at the next one. 5,400 inches is equal to how many miles? Well, an inch is a very small unit compared to a mile. So I'm going to need to go through several steps to get to eventually where my label is miles. And each time I move, I'm going to be asking myself, because I need to get to a larger unit, I'm going to be asking myself, well, what would be the next logical larger unit when I'm measuring distance? So when I start, I'm going to start by writing what I am given. And if you want, you can write that just over 1 to help you see the relationship. And then I'm going to ask myself, what would be the next logical larger unit or label that I would use wherein I could find a certain number of inches equal to something else. Well, when I look right back up here, I can see that I already have written one. I know that 12 inches is equal to a foot. And the next larger unit of measure when you're using inches is 1 foot. That's your ruler. Now, because I have inches and inches diagonally across from each other, I can cross those out. So my only unit of measure here is feet, but they want miles, so I have to keep going. When I look back up here, I know I'm going to want to look for the next larger unit for feet. Or I'm going to have to look for feet and miles. Well, lucky for me, right here, I can see that they gave me how many feet are in 1 mile. The other thing I could have looked at here is that 3 feet is equal to a yard. And if I have time, I might come back and use that one and show you how that would have worked out. But for right now, let's use 1 mile and 5,280 feet. Well, when I looked back down at my structure, I can see that I have feet up here, and I'm really wanting to have miles as my label. So I know that the number of feet that I have is going to go as my second term, and I'm going to write that there's 5,280 feet, and that is in 1 mile. Now notice I have feet diagonally opposite from each other so I can cross them out. I also see that my top unit of measure now is miles, and that's what I want. So I can multiply straight across the top and straight across the bottom and see how many miles I have. Now I can also cross cancel the numbers. So, but I can only do 2 of these at a time. In other words, I can look at these 2 and see if I can cross cancel there. I can look at these 2 and see if I can cross cancel there. Or I can look at these 2 and see if I can cross cancel there. So I notice right away that I have zeros in these 2 numbers. And so I know that I can at least divide this by 10 and divide this by 10, which is basically crossing out one of the zeros. 5,280 divided by 10 is 528. 5,400 divided by 10 is 540. So now I've reduced those numbers a little bit. They aren't so large. When I look at my 12, I notice that one of the factors of 12 is 3, because 3 times 4 is 12. And when I look up here, when I look at the digits in 540, if I add them together, 5 plus 4 plus 0, that's equal to 9. Well, 3 is a factor of 9. So I know that 3 will divide evenly into 540. So I can cross out my 12 and divide it by 3 and get 4. And I can divide 3 into 540 and I'm going to get 180, I believe. So I think I'll just leave it as that. I could continue cross-canceling. And I think actually 4 is going to be a factor of 180. But I'll just go ahead and use my calculator. And I'm going to multiply straight across the top. 180 times 1 times 1 is just going to give me 180, and that's miles, my label. And then down here, down below, 528 times 4 is 2,112. So now I can simplify this. Because typically when we're talking about miles, we don't use fractions unless it's like half of a mile or 3/4 of a mile. But I generally don't represent miles using these kind of fractions. So the best thing to do here is to convert this into a decimal by dividing the numerator by the denominator. And I'm going to get a repeating decimal. So right after this 2, you can see it starts repeating 27, 27, 27, 27. And we know that we would get, if we got a decimal that goes on, we know it's going to be repeating because we could represent it here as a fraction. So I'm going to round this, and I'm going to round it to the nearest thousands place, which means this 2 is going to tell me to leave that 5 as a 5. So my answer is going to be 0 and 85 thousandths. And that is my approximate answer. So I'm going to use the squiggle marks. And what that is telling me is this isn't even equal to 1/10 of a mile. This is a really small amount of a mile. 5,400 inches isn't even equal to 1/10 of a mile. It's really a small part of a mile. Okay, this one is not up in our chart. And the reason it's not up in our chart is because most kids know about weeks and seconds and minutes and so on. So I didn't include those up there. But again, we're going to start with what we're given. We're given 16 weeks, and we want to multiply that by a ratio that has weeks as the second term. So when we think about a week, we're going to a unit that is a smaller unit than weeks. So we want to start with weeks and work down to a smaller unit. So on this one, we would ask ourselves, what is the next smallest unit for a week? Well, that would be a day. So we know that in 1 week, there are 7 days. So now I can cancel my weeks out, and I'm left with days. But I need seconds, so I need to keep going. What is the next smaller unit in a day? So I'm going to have a day down here. And I know that the next smaller unit for days is hours. And there are 24 hours in 1 day. So I'm going to cross cancel my days, and I'm left with hours, but I'm still not at seconds. So again, ask myself, what's the next smaller unit from hours? And that would be minutes. So in 1 hour, there are 60 minutes. Cancel, cancel. Now I'm going to go to minutes on the bottom as my second term, and I ask myself how many seconds are in a minute, and that's going to be 60 seconds in 1 minute. So in this one, you can see that all across the bottom I have ones. So there's no numbers to cross cancel because all of the numbers in my second terms are ones. So my only option is to do this multiplication across the top. And when I do that, I'm going to get a very large number. Oops, not that large, I made a mistake. 16 times 7 times 24 times, I know that 6 times 6 is 36, so that's going to be 3,600. I didn't key in 3,600 times 7 times 24 times, I'll just do 60 times 60. There I go. 9,676,800. So 9,676,800. And that is seconds. That's a lot of seconds, but that's a lot of weeks. Okay, the last one. 54 yards, and I want to go down to millimeters. So I need to look up above and see what kind of units for conversion I have for yards, because I want to be able to cross cancel my yards. So when I look up here, I can see that I have 3 feet are equal to a yard. And I don't see yards anywhere else. So I'm going to have 3 feet over 1 yard. And I'm going to cross cancel my yards. And again, if you want to put this over 1, that is okay to do. So now I'm going to have feet down below. and I need to get to millimeters. And if I look up above, I will notice that I don't have any millimeters, but I do have centimeters. So that might be one that I want to use a little later. And notice that is associated with inches. Well, I'm not at inches yet, I'm at feet. But I do have 12 inches equals 1 foot. So I'm going to put 12 inches here and 1 foot here and cross cancel my feet. So I'm getting closer. Now I can use my inches and my centimeters, and I can put 1 inch down below and 2 5/400 centimeters up above, and then I can cross cancel my inches. Now, I want something that is going to tell me how many millimeters is in a centimeter. Well, here is a ruler that is divided up into centimeters. This is a centimeter, this is a centimeter, this is a centimeter. I like to tell my students that it's always a good idea to have a body part that you can use for measuring if you don't have a unit of measure like this. And you can see that my little finger is about a centimeter wide. So the distance from here to here is a centimeter, here to here is a centimeter, and so on. And if I count the units, these little tiny ones that are about as wide as the tip of my pencil, those are millimeters. And there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 millimeters in 1 centimeter. So over here, I can write that there in 1 centimeter, there are 10 millimeters. So now I can cross out my centimeters, and I'm at millimeters, which is what I want to be at. So I can go ahead and notice again all along the bottom I just have ones, so I'm going to need to multiply these numbers together, and I know that 3 times 12 is 36, and 36 times 10 is 360, so I'm just going to take 54 times 360 times 2 5/54. And my answer is 49,377 6/10 millimeters. The last problem. So this is an example of how you can apply dimensional analysis in an everyday situation. So this says you are throwing a pizza party for 15 people. You guess that each person will eat 4 slices. You call the pizza provider and you learn that each pizza will cost $14.78. Each pizza will be cut into 12 slices. How much will you have to pay? You have $70. Will you have enough money? So when we have a lot of information in here, I find it helpful to go through and kind of isolate it and make sure I can find it. So I know I'm going to have 15 people, and we think that they're going to be eating 4 slices per person, and you learn that the cost will be $14.78, and that each pizza will be cut into 12 slices, And what I need to end up with is how much I'm going to have to pay. So when I think about the unit that I need to end up with, this unit is actually not going to be something that I pick up and measure with. It's not going to be a gallon. It's not going to be inches or centimeters. It's not going to be time, but it's going to be money. Money is a unit of measure. So at my very end, I want to have dollars, but I'm starting out with people. So I'm going to start out with my 15 people. And what do I know about my 15 people? Well, my very next sentence says, I'm going to guess that each person, each means one, each person will eat 4 slices. So here I've got people, here I have one person. So I'm going to multiply one person as my second term, and I'm going to say that that one person is going to eat 4 slices. So now I'm going to cross out my label for people. So now I have slices. I need to find in my word problem, where else do I have some information about slices? Well, my next sentence says you call the pizza provider and learn each pizza will cost $14.78. That doesn't have anything about slices. Each one will be cut into 12 slices. Aha! Here I have 12 slices. 12 slices, each one. That one is one pizza. Each one pizza will have 12 slices. So I'm going to take these slices and I'm going to cancel them out. Now I have pizza here. I want to end up with dollars, so I know I'm not done. And it tells me, let's see, I've used this piece of information, I've used this piece of information, I've used this piece of information, I have not used this piece of information. Each pizza will cost $14.78. So one pizza will be $14.78. What do you know? I've got dollars. And I can cross-cancel my pizza. So I am done setting up the dimensional analysis structure, and I can now look and see if there are things that I can cross-cancel. Well, I've got 4 slices and 12 slices. I know that 4 is a factor of 12, so I can divide by 4 here. 4 divided by 4 is 1, and 12 divided by 4 is 3. Aha! I know that 3 is a factor of 15. 3 divided by 3 is 1. 15 divided by 3 is 5. And now all I have on the bottom are ones. 1, 1, 1, 1. So now I just have to multiply straight across the top. And I don't have to divide by anything. So I want to find out what $14.78 is times 5. So $14.78 is $73.90. So that is what I think I will have to pay if I want to have 15 people and 4 slices for every person and my pizza costing this much. How much will you have to pay? I'll have to pay $73.90. I have $70. Will I have enough money? No, I do not have enough money. I'm short $3.90. Maybe I can borrow that from my brother. Okay, so that's an introduction to dimensional analysis if you haven't seen that before. And we will be doing more of this in the future.